Hello and welcome to this tutorial on implicit differentiation. Today I'm going to be talking to you about the theory behind implicit differentiation and how we use the chain rule to differentiate implicitly with respect to any variable. And then at the end of this video I'm going to show you a bit of a shortcut to make sure that you're not wasting time using that chain rule every single time to solve these types of problems. Let's look at the first question that I've put up here. X plus y squared equals 4. We want to differentiate this equation with respect to x. So I'm just going to write this out explicitly for you using the chain rule. So I'm going to derive the x with respect to x. Then we're going to derive the y squared with respect to x. And then we have to derive the 4 with respect to x. Now the first term is pretty easy. The derivative of x with respect to x is just 1. This is where it gets a bit more complicated. We're going to use the chain rule to help us differentiate y squared with respect to x. Now the only way I can differentiate y squared is if I differentiate it with respect to y, and then we times that by dy by dx using our chain rule. So we're going to differentiate y squared with respect to y first, but we want to differentiate it with respect to x, so we're going to times this by dy by dx. And what you'll notice is that the dy's will cancel out, and then it's still dy by dx of y squared. And we know that the derivative of any constant, doesn't matter with respect to what variable, is going to be 0. So let's finish off the question now. 1 plus the derivative of y squared with respect to y is 2y. And then we have to multiply that by dy by dx, and that's all going to equal 0. And again, we're looking for what dy by dx is. So what I'm going to do is we're going to move the 1 across the other side, and then we're going to divide it by 2y. So let's move the 1 across the other side, so that becomes a negative 1. And then to get rid of the 2y, we divide the other side by 2y. So dy by dx is going to be minus 1 over 2y. So let's just go over again what I did there. I wrote it out, deriving each term independently with respect to x. Then using the chain rule, because we can't derive y squared with respect to x as it is, so we'll derive it with respect to y first, and then we'll times that by dy by dx, because using the chain rule, that's the same as deriving it with respect to x. And then what we'll do is we'll move all of the terms to the other side, and we'll factor out the dy by dx's that we want. Let's try another question. What if we had x squared plus xy equals 8? Again, writing this out explicitly, we are finding the derivative of x squared with respect to x. Then we're going to find the derivative of xy with respect to x. And then we're going to find the derivative of 8 with respect to x. Now the derivative of any constant is just 0, so I'm not going to worry about that one there. The first term is pretty easy. The derivative of x squared with respect to x is just 2x. This one's a little bit more complicated. What we have here is the product of two functions. I'm going to call this my function u and this my function v. When you're finding the derivative of a function multiplied by another function, we have to use the product rule. So the product rule states that the derivative of u times v is the derivative of u times v plus the derivative of v times u. And we're going to be using this rule to help us solve this part. So we're going to find the derivative of x, so that's the derivative of my u function, times my v function, plus the derivative of my v function times my u function. And that's all going to equal 0. So that's u prime v plus v prime u. And notice that I'm not differentiating this with respect to y, because when we're finding the derivative, it has to be with respect to the same variable every time. Alright, so let's move on. The 2x doesn't change, plus the derivative of x with respect to x is 1, times my y value plus the derivative of y with respect to x. We're going to use the chain rule again, so we're going to find the derivative of y with respect to y, and then we're going to multiply that by dy by dx. And then that's all going to be multiplied by x, and that's going to equal 0. So now we just need to simplify this out a little bit. We're going to have 2x plus y. Now the derivative of y with respect to y is 1 times dy by dx, all multiplied by x, and that's going to equal 0. And again, we're looking for what dy by dx is, so we need to move the 2x and the y to the right hand side, and then we need to divide that by x. So my dy by dx is going to equal minus 2x minus y, all divided by x. So in the previous two examples, we had only one y term that we're looking at. Let's look at what happens if we have two y terms and we're trying to derive it with respect to x again. This is the last time I'm going to do this, but I'm going to write it out explicitly. So we're trying to find the derivative of each term with respect to x. So that's what that looks like there. We're deriving each term with respect to x. Alright, so let's just look at this first term here. The derivative of y squared with respect to x, we can't do it. So again, let's use the chain rule. So d by dy of y squared times dy by dx. So that's that first term taken care of. Now the second term, you'll notice that we have a u function and a v function again. And again, we're going to have to use the product rule to find the derivative of this term here. So what that looks like is plus the derivative of u with respect to x times the v function plus the derivative of the v function with respect to x times the u function. And the derivative of x squared with respect to x is just 2x. That's the easy bit there. Alright, now we can just clean this up a little bit. The derivative of y squared with respect to y is going to be 2y times dy by dx. The derivative of x with respect to x is 1. 1 times y is y. Plus, we have to use the chain rule here again. So we have to find the derivative of y with respect to y, and then we'll times that by dy by dx, and then multiply that by our x term on the right there, and that's all going to equal 2x. So we have 2y dy by dx plus y plus, now the derivative of y with respect to y is 1, so this just becomes x times dy by dx, and that's all going to equal 2x. Now you can see here we have two dy by dx terms. So have a think for yourself for a second. How can we get those two dy by dx's into 1? Well, we're going to factorize them out. So we're going to have dy by dx times 2y plus x. So I've just factored out the dy by dx's. And that's going to equal 2x. And the way we get rid of a positive y on this side is we'll take away y on that side. Now, what we have to do is we have to get rid of this 2y plus x. There is a multiply between the dy by dx and the 2y plus x. So to get rid of that times 2y plus x, we'll divide it by 2y plus x. So we're going to end up with dy by dx is 2x, subtract y, all over 2y plus x. Alright, so I've done 3 examples with you so far that show you how to differentiate implicitly with respect to x via the chain rule. Now that's quite a tedious and long process, so what I'm going to show you now is the shortcut to differentiating implicitly. Let's assume that I have some term y squared and I want to differentiate it with respect to x. All you do is you treat this like it's the x term and you derive it, so the derivative of y squared is 2y, and then you put dy, which is the variable I'm looking at, by dx, the variable I wanted. Let's do another one. If I gave you y plus 2y cubed, and we wanted to differentiate this with respect to x, all you do is you derive each term with respect to x. So the derivative of y is 1, and then we're going to put dy by dx on the end of it, plus the derivative of 2y cubed is 6y squared, and then we're going to put dy by dx on the end of it. Let's look at a little bit more of an interesting problem. What if I had something like x squared plus 2y cubed, and I wanted to differentiate that with respect to t? Okay, so notice that there's no t variables there. The process is still going to be the same. So let's derive x as if it was a t variable. So the derivative of x squared is going to be 2x. And then all we have to put is dx, the variable I have, by dt, the variable I want to differentiate with respect to. Then let's do the second term here. The derivative of 2y cubed is 6y squared again. And then I'm going to put dy, the variable I have, by dt, the variable I want to differentiate with respect to. And this process is very good for our related rates problems that we're going to look at later on, because we're going to be deriving x and y terms with respect to t to find out how they change with respect to time. Alright, so using that information, let's see if we can differentiate the sine of y plus cos of x equals y squared plus x squared. And we want to differentiate this with respect to x again. So let's just use the shortcut method. The derivative of sine of y is going to be cos of y. And then all we do is we put dy by dx. Then the derivative of cos of x is minus sine of x. And we don't need to put dx by dx because that's going to be 1. The derivative of y squared is going to be 2y. And we're differentiating it with respect to x. So we're going to put dy by dx in the end there. And the derivative of x squared is 2x. So we'll put a plus 2x there. Now notice how I've got dy by dx on both sides. So let's move them both to the same side. So I'm going to have cos of y times dy by dx minus 2y times dy by dx. And that's going to equal 2x, which is that term over there. And let's move that minus sine x to the right hand side. So that's going to be a plus sine of x. So again, I've got two dy by dx's. The way we get around this problem is we factorize them out. So dy by dx times cos of y minus 2y equals 2x plus sine of x. And then to get rid of this times cos y minus 2y, we divide it to the other side. So dy by dx is going to equal 2x plus sine of x all over cos of y minus 2y.